Hello, 8th graders. Today we are going to go through Chapter 7 in our Tectonics iBook. Chapter 7 is about tsunamis, and we've talked a little bit about tsunamis already, particularly when we're talking about convergent plate boundaries. So this is a fairly short lecture. The word tsunami is a Japanese word that means harbor wave, but tsunamis don't just happen in harbors. Some people also call them tidal waves, but they have nothing to do with the tides. Those are caused by the gravitational pull of the sun and the moon. Tsunamis are generated. They're large waves that travel at very high speeds over a huge area, and they are generated by some sort of a jolt to the water. Most often, they are triggered by earthquakes, and even more often, they are triggered by convergent plate boundaries. But any kind of plate boundary movement can actually trigger one, and they can also, though a lot less frequently, be triggered by like a meteorite impact falling into the ocean. That can cause a large tsunami as well. Tsunami waves have small wave heights relative to their long wave lengths. And what I mean by that is if you drew a bunch of waves, okay, or if you even think of like a seismogram, how, you know, the peaks and the valleys of a seismogram, the wave length, it says they have small wave heights relative to their long wave lengths. So there's a lot of space in between the peaks, and there's a lot of space in between the valleys is what that means. So tsunami waves go up, and then there's a big space, and then they go up, and there's a big space, instead of going like this, okay? And what that means is that sometimes the trough of a wave, instead of the peak, the trough of the wave can make landfall first. And that is actually something that that people who live in tsunami-prone areas watch for, okay? So one of the signs that a tsunami might be coming is after an earthquake, if you are in an area that actually had the earthquake or felt the earthquake or had a warning about the earthquake, if the water retreats out to sea and uncovers a lot of sea floor, just like a big wave coming and the water goes out first before it comes in, it can retreat meters and meters out to sea. And that is one of the signs, because the trough hits first and it makes the water recede, and then the big wave comes in. Well, the problem is that tsunamis are tsunami-prone areas are usually island areas, beachy areas, areas where there's a lot of tourists, and a lot of people don't understand that. So one thing that has happened in our past is people being out on the shoreline and seeing the water retreat and having all of these shells and living organisms uncovered. Well, what do? They walk out to go check it out, and kapowie, a wave comes in. Okay, and that actually happened in 1755 in Portugal. A tsunami trough hit land first, and because there was a large earthquake on land, people kind of sought refuge on the shore to get away from the tumbling buildings and crumbling buildings. And when they went out to shore, they walked out to sea because the trough hit first, and they were taken out by the large tsunami wave. Most often, a tsunami will happen at a convergent plate boundary, okay? So where they're coming together and one is subducting, all right? So wherever you see specifically oceanic crust coming into contact with a continental crust or a continental boundary, oceanic boundary, continental boundary, the oceanic boundary will subduct. And when that happens, it drags the leading edge of that overlying plate for years and years and years and years and years. And eventually that energy will build up so much that the rock can't withstand it anymore, and it will pop up. And when you pop up like that, you create this bulge of water on the surface of the earth. Imagine your hand in a bucket of water that's nice and calm on the top, and you jerk your hand up really quick. That's going to create a bulge of water on the top, right? And that's going to go out in all directions. In deep water, we don't really see that. It might even go unnoticed at sea. Okay. When traveling up a slope onto the shoreline, however, the wave is pushed upward. Okay, so say my elbow is where you're standing on at the seashore. Okay, and this right here is the seafloor. It's getting shallower and shallower and shallower as you get to where people live, right? So a wave is coming in. Once it hits the shallower water, it's forced upward. It has nowhere to go but up because it's getting shallower and shallower. And the seafloor is actually, the friction of that is actually slowing the bottom of the wave down. So it grows up and over and then slams into the earth, okay, or slams into the shoreline. Just like any other wave, it will then retreat, which is a problem because the wave sometimes can rush in for a couple miles inland and take all of that stuff out to sea, and then sure enough, what comes back? Boom. All your stuff, but in a very unorganized fashion. These waves can travel very, very fast, up to 500 miles an hour, and they can be hundreds of miles long along the plate boundary, or wherever those boundaries have broken, shifted. Sometimes that goes the entire extent of the tectonic boundary. If you think of where some of these boundaries are, like if you look around Japan, if you look anywhere around the Ring of Fire, so around the Pacific Plate, that Pacific Plate has a lot of convergent boundaries all along the outside of it. It runs into a lot of other plates. A lot of the places that are involved in those plate boundaries are island nations. Okay, so especially if you look down by Japan and south of Japan, that whole area, Sri Lanka, all of those areas, they are really prone to getting a lot of tsunamis. And because they're island nations, they are not very able to deal with them. A lot of times tsunamis do, actually, when there is a big tsunami, they do a lot more damage than the original earthquake that triggered them. We can kind of withstand the shaking and the quaking, but when there's a huge rush of water that comes in, that causes some major problems. And just like earthquake preparedness, areas that are prone to tsunamis do have a lot of safeguards in place. They have tsunami warning systems. They have flood walls built up around their cities on their shorelines. A lot of things to try to decrease the damage from a tsunami. But again, if you're going to get into a war of wits with the power of the earth is always going to win, right? There's not much we can do when we have a really large tsunami. A very large one hit Japan in 2011 and Sri Lanka in 2004. Those were two of the most recent horrifying disasters. If you are interested in the Sri Lanka tsunami, go ahead and click on this link here. You can find this in Chapter 7 in the iBook. Otherwise, I am just going to post this video right here, and I'll have a question that goes along with it, okay? And that is it for this chapter on tsunamis. I hope you're well.